Again, my name is Marcelo Gallardo, and today I am very pleased to share with you what we are going to do is we'll do a very quick review and understanding of what distributed video analytics are and different solutions. And we will also do a quick demonstration of how TIBCO Project Air can help you some of the things that we're going to discuss. So let's start with on-premise solutions where all is done in a specialized software for each camera and protocol. As I said, we will start with on-premise solutions where all is done by a specialized software for each camera and the different protocols. As we can see, it requires a lot of human resources and it's not really scalable. Scalability was improved by moving processing and monitoring to central locations on the cloud by providing protocol normalization at the edge. While this helps with the scalability, the data path becomes long and the latency is also increased. Also, we can see that human resources are still needed for monitoring these large amounts of data. Next, adding machine learning models to infer the data helps with reducing the dependency on humans to monitor these large amounts of data. This still doesn't solve the issue with latency, bandwidth, and amounts of data that are needed to be moved on the network. Adding pre-processing at the edge, like filtering and rules, help us reduce the amount of data that we put on the network. Next, moving models to the edge help further reduce the volume of data on the network and also reducing the latency for near real-time scenarios. To reduce the data path further, models can actually be run next to the devices, like companies like AWS provide appliances that allow the cameras or your video devices to connect directly and feed that data into the models and then proceed with the regular path for processing after the model is evaluated. And finally, to reduce the data path to zero, models can actually run on the device itself on what we call the software on module. There is no latency from the camera to the model. And in this scenario, you can achieve the maximum number of frames per second produced by the camera. So with all the trade-offs, we need to understand what the costs are, whether it's latency costs, bandwidth costs, amount of data you need to move. We need to consider where the analytics need to run. Maybe at the end device itself, at the camera, the point of sale, as we just described it, or it can be on an edge device running on premises, taking information from the devices to make decisions close to real time and making immediate actions. Or it can be on the cloud where we have traditional set of analytics and integrating with all the third-party software and vendors. And of course, you have your enterprise applications. These are the software applications that keep your business running day by day and can be running in a data center or in the cloud. The point is that all the analytics that are being done on the lab, approaching your enterprise applications, are trying to bring business value, bring actionable insights back to where we need to use them. So with this quick introduction, let's move on and I will give you a quick demonstration of how TIBCO Project Air can help you solve some of these issues that we should discuss. So let's switch back to Project Air. So we have login and we are in our introduction page and we'll get started here. So as we have discussed in previous sections, the Project Air allows us to see the different locations where we have devices and we can examine each of the devices, and also it allows us to create business processes that can be run either at the cloud or next to the devices or in the device itself. So for this demonstration, I am going to use the use case where the model is actually running on a camera, and once that the model is evaluated, the data is pushed into into the project area infrastructure, and we can do whatever we need with that data. And the second use case is where a camera is just sending data to the project area infrastructure, and then we're going to capture that data, call a model, and then we will capture the results and send those results to the cloud. So let's get started. So for the first use case, it's very simple because the camera has been already, it's running and the model has been deployed. So the only thing we need to do is just subscribe to what that camera is sending. So we just create a data subscriber activity in our pipeline editor. And here we select the protocol we want to listen. So in this case, we are going to listen everything that's coming from edge devices. Once that is done, the next step is just, we want to publish those results to the cloud. So we create a data publisher activity and connect that and connect the activities. And here we select where we want to send. So we want to send this to a MQTT cluster that we have running on the cloud that is listening for events, and we are using that data to display the data here in the project area visualization. We will show you that in a minute. Once that is done, we can give it this process a name. So we'll call it demo camera. And here we are able to select where we want to deploy this process. As we just discussed on the slides, we have to decide and see the trade-offs of where we want this data to go. In this case, the data is actually evaluated by the model at the camera itself, so we don't need to worry that much. So, but we could still deploy this at the cloud or at the edge. In this case, for this demonstration, I am going to select edge, and here we also select the deployment method, the deployment type that we want to use. In this case, we will use the air deployer. Once that is done, we can say the pipeline, and we can see that is available with the other pipelines that we have created previously. And once that is here, we can actually proceed and deploy the pipeline. For these demonstrations, if we don't have the time to go over to the whole deployment, since that takes a few minutes, I will skip that step. But I will go back and examine what happens with the data that we are receiving from that model. As I said, the model already evaluated at the camera cell, and we're just receiving all those results here. So we go back to the gateway and go to the details. And here we can examine, there's two devices here that have been configured. And the one that we configured this model for is the OAK camera. This one has the model running on the device itself. So now we can go to and examine the three different things that the model is sending us. It's sending us the snapshots that the model take, and also taking the model is evaluating how many masks the model identify in the snapshot, in the picture, and how many people with no mask was identified. So here, when I click on the snapshots itself, here we can see a history of all the different snapshots that we have received. So in this case, you can see here, this is one of the snapshots. And here we can see the results that the model evaluated this specific snapshot and was able to identify the people that have masks and doesn't have masks. And still, we can continue investigating different snapshots that were coming from the model. You can see we captured different pictures from the model. And again, if you want to explore more, we provide the capability to specify the start day and end day, and then you can query what we have received from the gateway and do things with it. We can also examine what the different other results that come from the model, in this case, the number of masks, and we can see a history on a period of time, like how many people has been using masks and how many people we have identified that is not using masks while going here to the number of no mask. So here on this, we can see that the majority of the time we have identified 0 people that has not been wearing masks. And here we can see there's a chance that we have identified 1 person that was not wearing mask. For the other scenario, we can go to the pipelines again. And in this case, we are going to be able to receive the data that's coming from a camera. And now we want to apply the model that we have configured here on the project area. So one way to define the models that we want to use, here we can go to the connections to the endpoints for this for each gateway, and here under there's a models tab where you can define your different models that you want to use in your pipelines. So here we have defined one for to recognize patterns. So that's from a picture that's coming from cameras taking pictures on the wafers on a manufacturing plant. So let's go back here to create a pipeline for that specific scenario. So I'll go to the pipelines. Again, I select a subscriber, and I want to subscribe to all the data coming from the devices on this gateway. Again, you can add any other activities here in the middle before calling the inference, but like filtering or streaming the data or whatever is required by your use case. But in this case, we're just going to call the inferencing activity. And here on the inference activity, what you need to do is select the model that you want to apply to the data that's coming from that devices. So in this case, I am going to use the wafer pattern recognition model, and then select what devices, what instruments I want to send to the model. So in this case, I want to select the wafer sensing camera that is sending this wafer snapshot. And again, here I selected. I can connect the data that's coming in the framework. Let me make sure that here I selected the edge. And then after I have the inferencing done, I can select publishing activity that will send the results that's coming from the model to, oh, I'm sorry, this is not subscribers. I have to put a data publisher. I want to send the results from the inferencing to the cloud. So I configure and select the protocol I want to send to the air cloud. And again, we just give it a name. So this, let's say, wafer demo. And again, we select the type. We want to deploy this to the edge, or again, depending on the use case, you could select this to be deployed to the cloud. Here we again select the deployer type, and that's it. And now we save the pipeline. And again, it's shown here on our table of all the different processes we have configured, and it's ready to be deployed. Here we can review all the different processes, and it's ready to deploy. Going back to review the data that we are receiving from this wafer sensing camera, since we haven't deployed the model yet, we will be able to see just what we have received previously. Like we can see the different pictures that we have from received from this camera, and this will be sent to the model. And then when the model evaluates, we will be able to see the results here under the inferred value. This concludes the demonstration, and if you guys have any questions, I'll be happy to answer.